Hello students. So till video lecture 9 we have covered part A from the textbook, and from the physics class notes volume 1 we have covered the topic refraction, laws of refraction and refractive index, and in this section you can prepare the theory questions from 1 to 26. We have also done the topic of refraction of light through rectangular glass block, where you can prepare the theory questions from 1 to 8. Now in this lecture I will be solving some numericals from practice problem 1. So I will be solving the numerical number 1, 3 and 6. The remaining numericals from the class 4 section and the homework section, you can solve it by your own. So starting with the first question, a diagram has been given where we have to find angle of incidence, angle of refraction and refractive index of the liquid. I will show it on the board that a diagram has been given where a ray of light travels from air to liquid, okay, and the normal has been given, this angle has been given 30 degree and this angle has been given 45 degree. So from this figure we are supposed to find out angle of incidence, angle of refraction, and in the second case we have to find the refractive index, that is mu. So from the figure itself you can say that, sir, this is air, this is liquid, light is traveling from air to liquid. So this surface behaves as the interface, this being the normal. So the angle made by incident ray with respect to normal is called as angle of incidence. So this will be a, but this angle has been given 30 degree. So from geometry you can say that if this is 30, this angle has to be 60 degree, and the angle made by refracted ray with the normal is called as angle of refraction. So since this angle is 45 degree, so this angle has to be 45 degree. So from the first part we can see that angle of incidence is 60 degree and angle of refraction is 45 degree. So to get the refractive index of liquid, we can use Snell's law, where we will write Snell's law as mu, which is equal to sin I by sin R. And now we know the value of I and R. So this can be written as sin 60 upon sin 45. Since these are the standard angles, you must be aware of the value. So it can be written as sin 60 can be written as root 3 by 2. Sin 45 can be written as 1 by root 2, where by solving these two values, okay, I'll get the final answer as root 3 by 2. All this mathematical part you can solve by your own. So for the first question, the angle of incidence is 60 degree, angle of refraction is 45 degree, and the refractive index of liquid is root 3 by 2. This mathematical section you can solve by your own. So starting with the question number 3, you can pause the video and read the question and then you can check the solution. So in question number 3, we are given refractive index of water with respect to air. See, refractive index of water with respect to air has been given 4 by 3, and what we are supposed to get is refractive index of air with respect to water. So if you can remember, in the section principle of reversibility of light, I had explained that refractive index of 2 with respect to 1 is the reciprocal of refractive index of 1 with respect to 2. So this question is very simple. So to get refractive index of air with respect to water, I can write 1 upon refractive index of water with respect to air, which can be written as 1 upon 4 by 3, which will be equal to 3 by 4, which is the required answer. Now we'll solve question number 6, which is a longer question. You can pause the video and read the question and write the necessary data given in the question. I will read it once, that orange light of wavelength 6600 angstrom traveling in air. So in question number 6, we have been given wavelength of orange light in air, which is equal to 6600 angstrom, and the light gets refracted in water, and if the speed of light in air, velocity in air, or you can simply write C, this has been given 3 into 10 raised to 8 meter per second, and the refractive index of water, mu of of water has been given 4/3. So from this given data, we have to find the frequency. Now we know that V is equal to F lambda, and you are aware that whenever a ray travels from one optical medium to another optical medium, the velocity and wavelength changes, but what will remain same is the frequency. So whether you calculate frequency of orange light in air or in water, it will remain same. The velocity in air can be written as F into wavelength in air. So frequency will be equal to velocity in air upon wavelength in air. So what is velocity in air? It is 3 into 10 raised to 8 meter per second, but wavelength has been given in angstrom. So you must be aware of the conversion that 1 angstrom is 10 raised to minus 10 meter. So instead of wavelength, I can write 6600 angstrom can be written as 6600 into 10 raised to minus 10 meter. Solving this value, you will get 4.54 into 10 raised to 40, and hertz is the SI unit of frequency. See, this mathematical part you can solve by your own. If I go with the second point, what it has been asked, we have to find the speed of light in water. So by using the formula for refractive index in water can be written as speed of light in vacuum to the speed of light in water. So the speed of light in water can be written as speed of light in vacuum to the refractive index of water, which is equal to 3 into 10 raised to 8 meter per second, and this is 4/3. Solving this value, you will get 9/4 into 10 raised to 8, which is equal to 2.25 into 10 raised to 8 meter per second. And if I solve the third part, where we have to calculate the wavelength of light in water. So using the formula for refractive index of water, it can also be written as wavelength of light in air to the wavelength of light in water. I have explained it in a topic of relative refractive index. So to get the wavelength of water, wavelength in water will be simply wavelength in air upon refractive index of water, which will be equal to 6600 angstrom upon what is refractive index of water, 4/3. Solving this mathematically, you will get answer 4950 angstrom. You can solve all these questions and you can solve the remaining question. Thank you.